Okay, so the plan for today will be to add bit shift operators and then see what we will add next to our big int class. So who would be a good candidate to add those? How about Mr. Leo? Would you want to try adding bit shift operations to our big int? Okay. Can you get a connection? Is everything working? It can always happen that the IP address change. Let me check that. $29, perhaps. Perhaps, yes. Does anyone remember what it was changed to? I mean, I can change it again. Let me just quickly check whether the IP address of the virtual machine maybe has changed. That may also be a problem from time to time. No, the IP address is fine. Okay, so where's the chat? Try this one, and if it doesn't work, then I'll change it to this one. Okay, try it. Okay, perfect. So the plan is like with the other operators we did last week. You create functions which return a new instance of the object, and then you can use them in the operators directly. Since we will have shift operators like shift and shift assign, so like with all the others. It requires an integer as argument. Well, we will have a function that returns returns a new instance. If we use the shift and assign operator, then we can assign it in the next instruction to this object. So just create a function called shift right, or which one we started with now? We started with shift left. So shift left. That takes the argument. Yeah. No, it takes this object. It makes a copy of this object, which is then shifted by the amount of bits specified. Mm-hmm. Yeah. Because you need to use the arrow operator and not the dot for the this object. This is a pointer and not a object instance. Okay. Well, the you are referencing the object, the m size of the object on which the operator was executed. The operator as such is not an object. It is a function on a object. Uh, try it out. Definitely not it. It's a very early beginning. It is much more complicated than that. Try it out. Let's quickly scroll up to see which type we are using currently, just to pick something that will make for a good demonstration. Scroll all the way up to see what the definition of chunk type. We have changed it a couple of times, whether it's currently set to int or to short. It's set to short. Okay, short is fine. Then make a test case. Hmm. Yes. But they are boring. Wait. Yes. Also, it will not be two chunks because that's like binary. It would be two chunks if it would be from hex. Uh, so every chunk is 16 characters. 16 bits. So you need to do something bigger. Yeah. Let me pick a test value for you. Let's go with something like f00f. Okay, so what this looks like is 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 and then the same thing again. And if we shift this and we have here the chunk boundary, then we will see if it works properly. Okay, now try shifting it and to print the result, of course. Yeah, you could also compare the result with what happens if you shift the integer variable of initialize to the same value. Mm-hmm. And print the results to the console also. Yes, that's the problem. But since we are so far, let's see how it fails. You will need the test case later on anyway, so it's not wasted work. It was hex. There probably is also one for bin. Two two two. STD. Let's quickly check if there is something. Mhm. Yeah, okay, I can do it for you. It's just slightly more complicated. Okay. At least that's what the manual says, but apparently we are missing an include. We need to add bit set. Zack. Yep. That will do binary. It's not the same method as used. So it's not direct. You create pretty much a string, which is a bit set with a given. 8 is probably too short. We should also go for 32 here. Now it should be fine. Yep. Okay, run it. Double click. Okay. It doesn't like that. Why? Okay, but that should in principle be fine. We just need to try again. We have some other things at the top. um, you have not allocated any memory in the shifted element. That's yet another issue. Mm-hmm. Also, you need to execute alloc data on the shifted variable, not on this object. And it needs the count in bits, if I remember correctly. So we had somewhere byte count there. Okay. Now it should work. Reset it. Yes, but it's more broken than I would have anticipated. Why is that? How much did you shifted it in the test? By 1, right? um, something's really broken. Interesting. So what I would expect is that the right result we have here, that is what it should be. And I would expect that this here to be broken like this. So 1, 1 would be fine. But here we would be missing, it would be a wait, no, sorry. Here would be a 0. Yes. Wait, is that so? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes, we shift a 1 in. Oh, that's fine. I mean, we can add spaces where the chunk boundaries are. So just the error should be that it doesn't take the one which it cut out here to the next chunk. But apparently it does this, plus it sets every second bit to 0 for whatever reason. That is not good. Let's rerun that. Shift that. Given the current length, we could, yes. We just need to add the function, or is it not? Okay, it's not protected, so we can access it directly. No, sorry, we need this line. So asterisk, and what was it? Shifted. Shifted okay, it's sorry, that's the wrong one. This one. But, let's see how this looks. Okay, so the to bin function is right, so it's really happening when we shift something. Interesting. So now let's try the unshifted one to see whether the read in was working properly. Would also be, of course, that it's not. Actually, we should write here what we expect. Okay. Yes, the from bin is broken. Why did we not find that? Sorry, from hex. Wait, if we load from hex should be working, but apparently it's also broken. I mean, we changed here a couple of things. So probably while changing something we broke it. So byte index is this thingy. Chunk index. Byte index, where are we using byte index? Chunk type, chunk, offset digit. And digit is let's just put a breakpoint and see what happens. So digit is A, it should not digit. A is not good. The string is shit. We need first to comment out everything that we are not that we don't need. Okay. Okay, so the X string is the right one. The digit is A. A is not correct. The digit should be F. Char is F. Okay. Put a breakpoint here. Let's add a few line breaks so that the breakpoint is more targeted. Yes?
Can you revert the last two formatting changes? Should there be an A? Small A?
Yes.
Yes.
That's the problem. Okay. So let's run it. Okay, so now we have the expected error caused by not taking into account the chunk borders. So now it's time to fix this. Well, you have a couple scenarios. So first of all, it can be such that you only shift a couple bits from one chunk to another, but you could also shift, for example, by 17 bytes, so really by more than one entire chunk. So you need to think of a procedure that will handle both cases properly. Uh, yeah, I would do it differently, but if you have a plan, then go ahead. I mean, what I would find helpful would be first to create two variables and set them up such that one holds the amount of chunks by which the value is to be shifted, and the second one holds the amounts of bits in one chunk by how many it is to be shifted. That would be a good starting point. No, like let's say if you have let's say we want to shift by 18 and we have 16-bit large chunks. So then bits would be 2 and chunks would be 1. Well, yes, but it would be easier if you just take the size of chunk type times 8. And it would be more efficient since it's something that the compiler then computes for you statically. No function calls needed. So if you want to just get the count of bytes in one chunk is size of chunk type times 8. Without this, it's completely static in this sense. That would work as well. I would just write size of chunk type because that's what our array is defined with. Yeah, times 8 of course. And in brackets just to be sure that further down operations will be executed in the order we want it to. I never trust compilers to obey the right order of operations in equations. I always put brackets everywhere, just to be on the safe side. Because if you assume it does it right and it won't do it right, then it will be a bug which might be very hard to track down. Yes. Perfect. Yep. Not necessarily. You can do it with the loop as you started it. Just that the I will not go to 0, but it will go to shift of chunks. Okay, and after the loop, because basically if we have like to shift by more than one chunk, then we will shift the we'll take the chunk further back, put it further to the front, and then we will terminate as soon as the next chunk further back would be at a negative index, because that would not work. So this is what the loop, how the loop is supposed to work. And inside the loop, you just need to take the right chunk from the current from this M data, and then so here you would need a temporary variable for your chunk data. Well, actually not. Yeah, a temporary variable is definitely good to have. So you assign the right chunk to it, and then you shift this chunk by the amount of bits, and then in the next step you check whether you need to add bits from the previous chunk, and if so, then you do it. And finally you can assign the chunk to your current element in the shifted variable. Yes, but the buffer can be in the scope of the for loop. It does not need to live between two invocations. You can use, because you will be writing to the new object to shift it, and you can use the data in this object. You can reuse the data in this object, so you don't need to have an explicit buffer outside of the for scope. I think alloc data initializes everything with zeros already, doesn't it? Don't we have a memset in alloc data? Yes. We don't need alloc data. We already did that at the top. Well, so as said, the loop takes a chunk which we will now have from somewhere within the integer, which now at the first iteration of the loop will become the first chunk of the new element. So that's the first thing to do. You need to pick the right chunk from this M data. Not really, because this is the chunk at the same place in both arrays, in both integers. But if we wanted to shift, let's say, by 17, then you would not take the chunk at offset 1, but you would take the chunk at offset 0, because the chunk at offset 1 will be completely discarded by the shift operation. That's quite exactly the opposite of what was intended. So the new object we are creating, there we want to fill all the chunks. So there in this loop you will access at I, but this M data, so from the object from which we are taking the bytes, there you will access them at I minus size of chunk. Yes. Yes, we need to check. So there are two scenarios when you are taking data from one chunk to the other. There is the option where you just shift the whole chunk and don't do anything, and there can be the option where you shift the chunk, but then you need to combine the data from two chunks, right? So you need to check whether this will be the case, whether there is a chunk with which you need to combine it. I mean, the easy thing to do maybe is try to write down like by hand the operation that would start with 101. and we want to end up with so we want to shift this by let's say 18. So 18 would be, I mean, okay, let's do it so differently. We want to shift this by 18, and the result should be something like this. So how would you achieve that? Well, that's no, that is too easy. That is too easy. We need more chunks for that demonstration. Or we shift by less. Let's go with more chunks. Let's say we want to shift this. Yep. Yeah. So first step is, wait, is that correct? No, it's not correct. It's not correct. So we shift this by 2. So we have here 1, 1. So we start with this without 2. We shift 2. Then we have 1, 1 from the other one. 1, 1. That should be right. So we shift first. We shift by 16. Let's just move everything, and then we shift by 2. Yeah. And if you think about the in between steps, so we start, and our initial shifted variable is just full of zeros. And then the first step will be we take this one, this thing here. No, we said we start from the top. So we know this doesn't care, so this one is the first one we take. So we take this thing, put it in the first place, and then we need to shift it by 2 more. So we do this, and at this point everything here is still zeros. Then for the next iteration, the next go through, let's separate it. So I like, so here let's start, it starts here. I is equals 2. We did this. Now we have the next loop iteration. I is equals 1. So now first what we do is, again, we take this time not this but this block, copy it here. I mean, that is of course not the nicest way to demonstrate it, because it does not really nicely shows the shapes. Let's make it like that. Let's write it down like this. So we take the next block, this one, put it here, then we shift it by 2, like we did with the other one, and now we have somewhere 2 bits which now need to end up in this chunk we previously created. So we picked is that bit shifted? So we picked the previous chunk. To the previous chunk, then we add the 2 bits, and then at this point we have everything complete. And we will not do any I is equals 0, because we quit early. So shift of chunks is 1, so this will not be executed. And what you have now is well, this part of the operation, but if we go for the next iteration, you need to check that if you make the shift operation, you will have some bits that you will be shifting out, which you want to then apply to the chunk at the index, at the previous index. That is one way of doing it. Is there any better way? Well, you do the shifting, yes. Um, well, you know by how much you are shifting, so you know that there will be lost bits. Well, there are two strategies. So one is as written down here, and the other strategy would be. So we start again for the second loop. Then you do those things. I think this would be an easier strategy. You do those things, and then here you would want to check that you know that since you know that you shifted by 2, you are taking a look on the next chunk, this one, and you check which bytes you would need, and then you here make the operation to. So let's say it like this: you are taking the 2 bytes from the next chunk you want to process, and then you add those bytes here, and then you have the first chunk completely processed and don't need to care of anything else. And at this point we will have just a variable like this, and then you do your I1 operation, and in I1 is then easier because you don't need to touch the first chunk anymore. It just is as it is. It doesn't change. What you do is basically you just take here the second chunk, shift it by 2, and then you can just apply it to the previous one. And here by checking the I variable you can know that you don't need to pull anything from the back, but because you know that the rest will be padded with zeros. So you would make a if condition where you check whether I is larger than your shift of chunks, and if it is larger, then you are in the first case, for example I2, where you need now to check the next chunk that you would access. So that would be yeah, just access the next chunk. Let's see if this will work out. You need to access it on this, since you have not yet copied anything to this chunk that you will be accessing now. You need this M data, not shifted M data. But it's not the right index. In the row above, you are accessing in this example the first chunk, and what you want to access in line 457 is the chunk which you would access during the next iteration of your loop. So if you see what you have as an index, what would be the index during the next iteration? Yes, that's it. And you need to assign it to a temporary variable. Now you need to ensure that your temporary variable will contain only the bits which you need. Yeah, try it. Sounds like there was somewhere one operation too much in it, but let's see what the result will be. I mean, buff you already have assigned the data, so the bytes. So now you just need to shift them by the right amount. Uh, well, if you start with chunk type, then you want to give a new variable name, I guess. The bitwise operators first have the integer in which you are shifting the bytes, and then the amount by how many you want to shift them. So you need to swap them. Also, you are shifting in the okay, you're shifting in the right direction. That's fine. But you need to shift buffer and not size off. Um, okay, there are two mistakes in this. First of all, you need to multiply a size of chunks times 8. And secondly, the two operands for the operation are in the wrong order. So the first operand is buff, and the second one is the amount of bytes to shift it. Just swap them. The shift is now in the wrong direction. Yep. That looks okay. So now you should only have the bits which you need, and now you can assign them to the current chunk. Mm-hmm. Mm-hmm. Yes. Okay, let's try it. Why? So let's see what we have here. So this thing, okay, this is just not shifted one, so it doesn't matter anyways. The first and the last one, it just looks like the first one is not. Sorry, that's the wrong thing. Anyways, this one we want to comment out. But it still didn't do what it was supposed to do. We shift only by one in this example. So we don't need this. Let's see what it shifts here.
I think the modulus and the division are swapped around.
Bits to shift one, chunks to shift also one. Yeah, but it's yep, they're switched. Okay, let's run it again. Yay, that seems right. Uh, okay, now we can also test the case where we want to shift by 17. So we add one more f to the equation and let's say shift it by 18 bytes. Integer 64. Yeah. Okay, that makes sense that this did not work as expected. We don't have room to shift to. Now it should be fine. Wait, no, sorry, it's 1 0 too much. Sorry, 1 nibble too much. Wait, 0, is this now? To start with this 4, 4. Wait, 1, 2, 3. No, that was fine. 4, that should be fine like this. So now both are 64-bit numbers. Okay, and here we need to also fix this. Yep, it's working. Perfect. So now we just need to add the right shift and we are done. It would be similar. It would be quite similar, but it would not be exactly the same. So you would need to access slightly different offsets and you would run the loop into the opposite direction. So you would not run it from the back to front, but you would run it from front to back.
One question, so what about growing the thing, you know, if you shift this left and there's not enough space?
Ooh, that is not how integers normally behave, but we could if we would wanted to. Yes, I would leave it as it is.
But that becomes then very ugly for the home number, for the multiplication.
Why?
I mean, because you might do a shift instead of a multiplication, and then you have a home number, so you would need to check this.
You can add a variable to your shift function where that should grow, like can grow true or false. And the cheap implementation is that you always add the bytes, even if there would be 0, and the better implementation is if you check whether the amount of bytes so if the amount of bytes from the left side by which you are shifting to the left, if it's not all zeros, then you grow it by the right amount, and if it's all zeros, you just leave it as is. Well, in line 454, you need to change the shift direction, I guess. No, why? It's always first the value and then how many bits you shift. Yeah, I guess you need to adapt the if condition as well. In principle, your if condition is the condition of the next iteration of the loop. So you just take the same condition as you have in your loop, and then you think of what would change for the next go through. So normally the loop counter will be larger by 1. Also, the loop condition should be smaller and not smaller equals. Wait, no, smaller equals is fine. Sorry, it's fine. Wait, you have yeah, that's fine. Well, that would be more or less the current loop iteration. You want to check it for the next loop iteration. So you need to add 1 to your I. A plus 1. Well, the shift direction in line 458 is not right. Wait, is it? No, it is. You already changed it. Okay. Wait. Yeah. Okay. Let's try it. Oh, wait. Let me see one more thing. Okay. So we assign this to I. There is, I think, one mistake. You are not taking into account the chunk shift when you are assigning to shift m data. Shifted m data. This line, but on the other side, yes. I think you have to subtract it. And of course in line 460 the same thing. That should be it. It works very good. Okay, so this works fine. What we are now still missing is the operator to shift and assign. It's like with the plus and minus operators, we always had the to something and assign variant. So it would be good to add those as well. Mm-hmm. Yep. Okay, perfect. That is done. So the next task for the next volunteer will be quite simple. Add two functions getBit and setBit. So getBit just takes the bit offset and returns the value of the bit at the given offset, and setBit does the same, just that also takes the value to be set, which can be true or false. Okay.
If it's a bit,
Mm-hmm.
what do I place it?
Yeah. It's
So it should. What should return a chunk from in the best?
well, getBit will return a boolean and setBit will return nothing.
So first of all, we need to find the right chunk.
Mm-hmm.
Should have a shorthand to find the best one.
That would be helpful. That would be indeed helpful.
So let's get the temp. Maybe some temporary variable, the chunk one.
Mm-hmm.
Okay. Now let's 1000. Good. So now we want to get the shift temp be right by bit minus one, or I'm always
No, not -1, just by bit index.
bit. Okay, and then
Well, by bit index. Mm-hmm. Yes. One thing that would be nice would be some handling in case chunk index is outside of the array. That might happen. I mean, users enter whatever they want, so it's always good to check. Yeah, either throw something or just return false. But let's go with throw. Just write access out of bounds or something. Um, yeah. Okay. Maybe uh, because there is a terminating null character which you don't see in the string. Let's take some of the bits from the second chunk. So I don't know, number 18 maybe. It should be a 1, I think. We could also extend the from bin and from hex functions that if they encounter a whitespace character, that they will just ignore it, so that we can have nicely formatted strings. Okay, then do it. Here's from bin. You would just check whether bin string at the index of I is equals space in brackets or backslash t in brackets, or maybe where we could also add backslash n and backslash r, but I guess just the normal space. You need a single quote since it's a character. Yeah. Um, no, you need to do it. You need to do it with before line. Yeah, somewhere here. Yes, before this ifs, and you can instead of bin string just go with ch. It's already at the right index. Wait. Let me think. Is it so simple? It's not so simple because we are using I later for the data, so we would need to have a secondary counter variable which will not be incremented if we continue here. Yeah. And where were we using it? Yes. Guess that's everything. There should not be more. Okay, now the same thing for bin. Um, No. Bin string must be from I because it's in the string. We need the block and offset variables to use here. Yeah. I mean, you should maybe then move the check above those two. Yeah. So these two i's need to be exchanged. Yes. And this should be moved to the very beginning of the. Yeah. Yes. Right. Yes. For hex should be fine since hex had a slightly different order of operations. Yeah. 8 is one. You somehow managed to make that 9, but yeah. Short is 16. Okay, it's fine. No, it's fine. Looks good. I was just thinking that in principle now in the to string so to hex and to bin function we also should add a variable where we can add the add a number every how many characters it should and insert the white space. Okay. Mhm. Mhm. Definitely. And L and L. Mhm. I think it's right, except that it has more zeros because it calculated the length, including the white spaces. Oh, that's not good. That is not good. Let me quickly see. Maybe it can be fixed quickly. So we have been a string. We check this. Current index. Short-term check this. That should be fine. Why wouldn't it be? This is strange. I mean, first thing we can do, 1, 2, 3. We can cut something from the beginning so that we will have the same length. It will add zeros here. At least that the lengths are matched, so it's easier to compare. Okay, it really seems like the offsets are wrong. Just shift that. But current index, we only increment if this is not. Shit, we are using bin string size as a. Yes, the white space is so far. That's ugly, but it should work. Nope, damn it. Why? Um,
But then do you still current index there, or do you define
probably I should be fine. I will be fine now, yes. Or not. I would say we just revert everything and we make the whole thing a homework. Because that will need just some playing around with the right indices that just eats time. Yes. Okay. So we just here. Okay, let's test the get bit function. And the mouse is moving, but it's moving slowly.
yeah, I guess it's an actuation.
Probably.
Back.
Is it now working?
Now.
Okay.
Bit better. Looks quite funny. I see it on the. Now. Back.
Get bit. Yes. We need to add a space. And then pick also one bit that is 0. So I don't know. Okay, yeah, that's also fine. You can go in a loop and print every single bit. I think it's called length. Oh, and your auto will not be string. Your auto will be char. That's why it doesn't work.
I thought I'd get around that.
No, it just takes the simplest thing it can. The I needs a minus minus, I think. It works. Okay, now we just need the set bit and we are done.
Yeah, right.
Yes. Um, yeah, in principle. Mm-hmm. Okay, and if value is false, and if value is false, if value is false,
Yes. Then
it doesn't do anything.
okay, so I should set this first. I should zero first the bit, or is it?
Yeah, yeah.
Okay.
Um, the simple well,
XOR with itself. Something like that.
no, that will not be good.
I
Wait.
was thinking you can use the current bit from temp and then essentially do a kind of a zeroing it.
I don't think sorting will work because you will always have a situation where a lot of your bits are still zero, so you will end up just clearing or setting too many of them. A simple strategy would be um, to check whether value is zero or not, and make shifted value, like for shifted value, use just one shifted by bit index, always one, whether no matter whether value is one or not. Yes.
So but it's a good idea to stick.
You need a shifted value shifted by the right amount of bits, but the value should always be a one at the index which you want to manipulate. So you use as the left operand not value but just one. No, in line in 491,
Yes. One. Yeah, I see.
and then you can check whether a value is true or false. And if it's true, then you just use the or as you did, and if it's false, you do something else.
So then it's
Then you want to clear it.
yeah. Now I want to zero it out. So the the way to clear it. So that would mean that we have zero all holding this position in temp.
Yes. Well, the definite way of doing something is to use an AND, but then you of course need to manipulate your shifted value accordingly.
Yes. So if shifted. So I need to check if shifted value.
Well, you always know what shifted value is. You would want to invert shifted value and then just end it with temp tilde operator. Uh, yeah. Mm-hmm. Yeah. No, it just equals 1 in brackets. Just the wrong brackets. Mm-hmm. We are missing a line break somewhere, but other than that, yeah. After this, the first loop, you should add a line break somewhere. Yeah, here. Yay! It's working. Perfect. 1 minute late. Yes. So, as we said, the homework for the next time will be 17, 11, 20, 22. Make from bin and from and tab. Just spaces. Once it works for everything. Yep. Sounds easy enough. Just needs a little bit playing around. Okay, so we are done for now. We will see each other in like 3.5 hours for the lecture, and that's that. Bye bye.